Good morning, everyone. Welcome to today's presentation. I'm excited to introduce you to our topic, BPCC-101, Introduction to Psychology. Today, we will be focusing on Unit 4, which covers perception, its types, and common errors. Throughout this session, we'll explore how we perceive the world around us, the different ways perception can occur, and the mistakes we often make in interpreting our surroundings. I'm glad you're here, and I look forward to an engaging and insightful discussion. Let's get started. Today, we're going to explore perception, focusing on its types and the common errors that can occur. Perception is fascinating because it allows us to experience the world in 3 dimensions, helping us judge distance, size, and movement accurately. It's essential for navigating our environment safely and meaningfully. In this unit, we'll look at how perception works and also why sometimes it fails. These failures can lead to interesting phenomena like illusions and hallucinations, which show us just how complex and sometimes fallible our perceptual processes are. Perception helps us interact effectively with our surroundings, but it can be misled under certain conditions. That's why understanding these errors is so important. It reveals the limits of our perceptual system and helps us better understand human experience. Now, focusing on what we'll cover first, we'll examine the different types of perception. For example, depth and distance perception, which tell us how we sense space and judge how far objects are. Then, movement perception, which allows us to detect and interpret motion around us. And finally, size perception, which helps us maintain constancy in size even when an object's distance changes. We'll also look at the errors of perception, how sometimes our perceptions are not accurate. Illusions, for instance, are false interpretations of real stimuli, tricks our brain plays on us. And hallucinations are perceptions without any external objects present, which can be quite intriguing to understand. So, through this exploration, we'll see both the incredible capabilities of our perceptual system and its vulnerabilities. This understanding is key to appreciating how we experience the world around us in such a rich and complex way. Let's explore the fascinating topic of perception, focusing on its types and the common errors we encounter. Understanding perception is crucial because it explains how we judge spatial relationships and navigate our environment effectively. It helps us see why sometimes our perception deviates from reality, revealing how our mind actively constructs meaning from sensory information. For example, illusions demonstrate how our brain's assumptions and the context around us can influence what we see, sometimes leading us astray. This unit is structured to cover several key areas. First, we'll look at depth and distance perception, which helps us judge how far objects are. We'll also explore monocular and binocular cues, which are essential for perceiving depth using one eye or both eyes. Then, we'll discuss how we perceive movement and size, which are vital for understanding motion and scale in our environment. We'll also examine errors of perception, those moments when our perception doesn't match reality. And finally, we'll delve into visual illusions that reveal the tricks our brain can play on us. By the end of this unit, you'll understand how we perceive space, movement, and size in our daily lives. You'll be able to recognize different types of perceptual errors and understand their causes. Most importantly, you'll appreciate how perception is a complex blend of sensation, past experience, and interpretation, shaping how we experience the world around us. In this slide, we're focusing on the objectives of this unit, which is part of our Introduction to Psychology course, specifically Unit 4 on perception, including its types and errors. By the end of this unit, I want you to be able to explain how we perceive depth and distance. This means understanding how our brain interprets the 3-dimensional world and how we estimate how far away objects are with accuracy. We'll also cover visual cues. These are the signals our eyes and brain use to judge depth and distance. You'll learn about monocular cues, which involve just one eye, and binocular cues, which require both eyes working together. Next, we'll explore how we perceive movement, direction, and size. It's fascinating to see how our brain maintains size constancy, so objects don't seem to change size as they move closer or farther away. We'll look into perceptual errors, too. These are mistakes our perception can make, like illusions, which are misinterpretations of stimuli, and hallucinations, where perception occurs without any external stimulus at all. Finally, we'll analyze some famous visual illusions like the Müller-Lyer, Ponzo, Ames Room, and moon illusion. We'll discuss what these illusions reveal about how our visual system works and the psychological principles behind them. Throughout this unit, the goal is to deepen your understanding of how perception shapes our experience of reality and how errors in perception can occur. Depth and distance perception are fundamental aspects of how we interpret the world around us. Depth perception allows us to see the environment in 3 dimensions, length, breadth, and depth, rather than as a flat, 2-dimensional image. It helps us understand the spatial relationships between objects. Distance perception, on the other hand, helps us judge how far or near objects are from us, which is crucial for interaction and movement. These 2 perceptions work hand in hand. Depth perception provides us with an understanding of how objects are arranged in space, while distance perception helps us estimate how far each object is from our position. Both rely on visual cues that the brain uses to reconstruct a 3-dimensional world from the 2-dimensional images projected onto our retina. In our daily lives, this ability is absolutely vital. It enables us to walk confidently, drive safely, catch a ball, or reach for objects accurately. Without these cues, our environment would seem flat and confusing, making everyday tasks difficult and potentially unsafe. That's why depth and distance perception are so essential for adaptive and safe behavior. Now, let's look at what forms the basis for these perceptions. They depend on visual cues, which we can broadly classify into 2 types: monocular cues, which are available with just one eye, and binocular cues, which require both eyes. Our brain integrates information from both sources to create a coherent and accurate perception of space and distance, helping us navigate our environment effectively. Now, let's talk about monocular cues, which are visual indicators that help us perceive depth and distance using just one eye. These cues are quite fascinating because they allow us to judge how far or close objects are, even when one eye is closed or unavailable. This is especially useful in everyday life, as well as in activities like art. In fact, many artists use monocular cues intentionally to create the illusion of depth in their 2-dimensional drawings or paintings. So, even on a flat surface, they can make images appear 3-dimensional and realistic by leveraging our brain's ability to interpret these visual hints. Understanding these cues helps us see how our perception of the world is constructed and how it can sometimes be tricked or enhanced. Let's talk about one of the major monocular cues, which is relative size. When we look at 2 objects that we know are similar in size, the one that appears smaller on our retina is perceived as being farther away. This is a really interesting way our brain interprets depth from just one eye. For example, think about people standing at a distance. Even though their actual size hasn't changed, they look smaller because they're farther away. This cue helps us judge distances in everyday life, especially when binocular cues aren't available. It's a great example of how our perception works to create a 3-dimensional experience from 2-dimensional images. Now let's talk about one of the monocular cues, which is texture gradient. When we look at a scene, surfaces that are closer to us tend to appear more detailed and coarse, while those farther away look smoother and finer. For example, imagine you're walking down a path and you see pebbles. Up close, the pebbles are clearly visible with distinct textures, but as they get farther into the distance, they seem smaller and more blended together. This change in texture helps us perceive depth even with just one eye, making it a crucial part of how we interpret our environment. Understanding these cues connects to the overall theme of perception by showing how our brains use visual information to construct a 3-dimensional understanding of the world around us. Now, let's talk about interposition, which is a key monocular cue for depth perception. When one object partly covers or overlaps another, our brain interprets the covered object as being farther away. For example, if you see a tree overlapping a building, you naturally perceive the tree as being closer to you than the building. This cue helps us understand spatial relationships in our environment, even with just one eye. It's a simple yet powerful way our brain interprets depth, fitting into the broader theme of how we perceive the world around us through various cues. Now, let's talk about one of the key monocular cues for perceiving depth from just one eye, which is linear perspective. This is a fascinating concept because it shows how our brain interprets depth based on how lines behave in our visual field. Essentially, parallel lines, like railway tracks, seem to converge as they extend into the distance. The closer they get to the horizon, the more they appear to meet. This convergence gives us a powerful visual cue that helps us judge distances and the spatial layout of our environment. An everyday example is how railway tracks seem to meet at the horizon, even though we know they are parallel in reality. This cue is crucial because it demonstrates how our perception of depth isn't just about what we see directly, but also about how our brain interprets these visual patterns to construct a three-dimensional understanding of the world around us. Now, let's explore the concept of aerial or atmospheric perspective as a monocular cue for depth perception. When we look at distant objects, they often appear blurred or have a bluish tint. This happens because of dust particles and light scattering in the atmosphere. Essentially, the farther an object is, the more atmospheric interference there is, which affects how we perceive its clarity and color. For example, when we gaze at mountains on the horizon, they tend to look pale and less distinct compared to objects nearby. This visual cue helps us gauge the distance of objects in our environment, even with just one eye. It's fascinating how our brain uses these subtle clues, like blurriness and color changes, to interpret depth and spatial relationships around us. Let's take a closer look at monocular cues, or depth perception from just one eye. One important cue is light and shadow, or shading. When we see patterns of light and shadow, they create a strong impression of depth and form. For example, if you look at a round ball versus a flat circle, shading differences help us distinguish the three-dimensional shape from a flat shape. Another key cue is motion parallax. This occurs when we move our heads or bodies. Nearby objects seem to move faster across our vision, while distant objects appear to move more slowly. For instance, when you're in a car and look out the window, trees close to the road seem to zip past quickly, whereas mountains in the distance seem to move very slowly or not at all. Now, why are these monocular cues important? They are essential for perceiving depth in art, photographs, and real life. Even if binocular vision is limited, these cues help us maintain spatial awareness. They give us strong hints about how far away objects are and help us understand the 3D structure of our environment, which is crucial for everyday activities and safe navigation. Now, let's talk about binocular cues, which are essential for our three-dimensional vision. These cues rely on both eyes working together to perceive depth and distance. Our eyes are approximately 6.3 centimeters apart, which is actually quite important because it means each eye sees a slightly different image of the same object. The brain then takes these two different images and merges them into a single, three-dimensional perception. This process is what creates our sense of depth, allowing us to judge how far away objects are and to perceive the world in 3 dimensions. Understanding this helps us see how our visual system constructs the rich, detailed environment we experience every day. Now let's talk about binocular cues, which help us perceive depth using both eyes. The first major cue is retinal, or binocular, disparity. This refers to the slight difference in the images each eye receives because our eyes are horizontally separated. Essentially, each eye sees a slightly different view of the world. Our brain then compares these two images to determine how far away an object is. This process helps us judge depth and distance. When the disparity is greater, meaning the images are more different, the object appears closer. Conversely, if the disparity is smaller, the object seems farther away. Let me give you a quick example. If you hold your finger close to your nose and alternate closing each eye, you'll notice the finger seems to jump or shift. That's retinal disparity in action. Your brain is detecting the difference between the two images and interpreting it as the finger being nearby. This cue is essential for us to navigate and understand our three-dimensional environment accurately, tying into our overall perception of depth and space. Let's talk about binocular cues, which help us perceive depth using both eyes. One key cue here is convergence. When we focus on a nearby object, our eyes turn inward, a process called convergence. Conversely, when we look at something far away, our eyes move outward or diverge. The amount of tension in our eye muscles gives us important information about how close or far away an object is. Generally, the more our eyes converge, the closer the object is perceived to be. Less convergence indicates that the object is farther away. Now, why are these cues so important? They provide high accuracy in judging spatial depth and distance, which is crucial for many everyday activities. For example, stereoscopic vision, the kind of three-dimensional perception we experience in real life or in 3D movies, relies heavily on binocular cues. They're also essential for tasks that require precise hand-eye coordination, like catching a ball, driving, or threading a needle. While monocular cues can give us some depth information, binocular cues tend to be stronger and more precise. Together, both types of cues work harmoniously to give us a complete and accurate perception of the depth and space around us. Let's talk about movement perception. Movement perception is essentially our ability to detect motion, speed, and the direction of objects around us, or even ourselves in the environment. It's really crucial because it helps us stay aware of where we are in space, ensures our survival, and supports coordination in our daily activities. Whether it's avoiding obstacles or catching a ball, movement perception is at work. Both real and apparent motion contribute to how we perceive movement every day. Real movement happens when an object actually changes its position over a period of time. For example, when a car moves down the street or a person walks across a room. Our brains detect this through signals from the retina, where images move across our eyes, and from our vestibular system, which is responsible for maintaining balance and spatial orientation. On the other hand, apparent or illusory motion is when stationary images seem to move. This can be a bit more tricky to understand, but is fascinating. Think of the phi phenomenon, which is what makes movies and animations appear to be moving continuously, even though they are just a series of still images shown rapidly. Then there's stroboscopic motion, which you might see in neon signs where flashing lights create the illusion of movement. So, in summary, our perception of movement is a mix of detecting actual changes in position and interpreting visual cues that trick our brains into seeing motion where there might be none. Both types are essential for how we understand and navigate the world around us. Let's now explore some related phenomena in motion perception. First, we have induced movement. This occurs when a stationary object seems to move because the background around it is moving. For example, you might have seen the moon appear to drift behind clouds, even though it's actually stationary. This highlights how our perception can be influenced by surrounding motion. Next, there's the motion after effect, often called MAE. This happens after you've stared at movement for a while. When you look away, a stationary object might seem to move in the opposite direction. A classic example is the waterfall illusion. After watching a waterfall, the rocks beside it seem to drift upward. It's a fascinating demonstration of how our visual system adapts. Now, why is movement perception so important? Well, it helps us judge the speed and direction of moving objects, as well as their relative position. This ability is crucial when we're driving, playing sports, or maintaining balance. It also enables us to anticipate motion, like catching a ball or avoiding obstacles in our path. However, if there are disturbances in how we perceive movement, it can lead to disorientation or motion sickness. That's why understanding movement perception is vital. It directly impacts our everyday functioning. In summary, movement perception integrates signals from our eyes, body, and environment to help us interpret motion. It's essential for navigation, action, and survival. Truly, it's one of the most dynamic and fascinating aspects of human perception. Now, let's talk about size perception. Size perception is essentially our ability to judge the true or constant size of objects, even when their distance or the angle at which we see them changes. Imagine looking at a car from far away. It appears small on our retina, but we still perceive it as a normal-sized car. This phenomenon is known as size constancy, and it helps us recognize objects accurately no matter how far away they are. So, how does this work? Well, Size perception depends on the interaction between the size of the image on our retina and our perception of how far away the object is. When an object moves farther away, its image on our retina gets smaller. But our brain compensates for this change by using contextual information, things we've learned from past experiences and environmental cues. These cues help us maintain a stable sense of an object's size, making sure we don't get confused by the changing size of the retinal image. In essence, our perception of size is a dynamic process that combines visual input with our knowledge of the world, allowing us to judge objects accurately despite the constant changes in what we see. Let's talk about size perception. Essentially, it is our ability to judge the true or constant size of objects, even when their distance or the angle at which we see them changes. Now, you might have noticed that as objects move farther away, their image on our retina actually gets smaller. Despite this, we still perceive them as being the same size. This phenomenon is called size constancy, and it plays a crucial role in helping us recognize objects accurately regardless of how far they are from us. Now, how does this work? Well, size perception relies on a dynamic interaction between two main factors: the size of the image on our retina and the perceived distance of the object. When an object moves farther away, its retinal image indeed becomes smaller. But our brain compensates for this change by using contextual information from our environment. Past experiences and environmental cues help us interpret the size correctly, maintaining a stable sense of the object's true size. So, in essence, our perception of size isn't just about what our eyes see directly. It's a sophisticated process where our brain integrates visual cues and previous knowledge to help us perceive objects consistently, no matter how their position in space changes. This understanding is fundamental to how we interpret and interact with the world around us. Now, let's explore errors in perception. While perception is generally quite accurate, it can sometimes deviate from reality, leading us to misinterpret or distort sensory information. These errors highlight that perception is an active process of interpretation, not a perfect mirror of external reality. The two main types of perceptual errors are illusions and hallucinations. Starting with illusions, these are false or distorted perceptions of real external stimuli. The stimulus is actually present, but our interpretation of it is incorrect. For example, mistaking a rope for a snake in dim lighting. Illusions often happen because of faulty context, ambiguous stimuli, or our psychological expectations. And it's important to remember, illusions are quite normal. They show us how much perception depends on interpretation. Moving on to hallucinations, these are different. They involve perceiving something without any external stimulus at all. Someone experiencing a hallucination might hear voices or see images that aren't really there. Hallucinations are common in certain mental health conditions, during high stress, or under the influence of drugs. Unlike illusions, which are distortions of real stimuli, hallucinations are internally generated and are considered pathological. So, understanding these errors helps us appreciate how perception, while powerful, is also susceptible to mistakes, whether through illusions or hallucinations, and reminds us of the active, interpretive nature of our perceptual processes. Now, let's look at some other sensory abnormalities that can occur. One such condition is anesthesia, which refers to the absence or complete loss of sensation. When someone experiences anesthesia, they simply don't feel anything in the affected area. On the other hand, hyperesthesia is almost the opposite. It involves heightened or excessive sensitivity to stimuli. People with hyperesthesia might find normal sensations painfully intense or overwhelming. Then there's paresthesia, which is a bit more unusual. It's characterized by distorted sensations or abnormal perceptions, like tingling or a false sense of localization, where sensations seem to be coming from the wrong place. These conditions highlight how differently sensory information can be received and processed, and they remind us that perception isn't always perfect. Now, understanding these perceptual errors is really important for psychologists because it helps us explore how perception normally works and where it can go wrong. For example, illusions demonstrate the constructive nature of perception, how our minds actively interpret sensory input, while hallucinations reveal more pathological distortions, often linked to mental health issues. Studying these errors not only deepens our understanding of normal cognitive functioning, but also provides insights into various mental health conditions. Let's talk about some other sensory abnormalities that can affect perception. First, anesthesia refers to the absence or loss of sensation, which can happen due to medical procedures or nerve damage. Then, there's hyperesthesia, where sensitivity to stimuli is heightened or excessive, making even minor sensations feel intense. Lastly, paresthesia involves distorted sensations or abnormal perceptions, such as tingling or false localization of stimuli, like feeling a limb is still there after it has been moved or numbed. These conditions highlight how variations in sensory processing can alter our perception of the world around us. Now, understanding these perceptual errors is really important for psychologists because it helps us explore how perception works and where it can go wrong. For example, illusions demonstrate the constructive nature of perception, how our brain actively interprets sensory information, while hallucinations reveal more pathological distortions, often seen in mental health conditions. Studying these errors gives us valuable insights into normal cognitive functioning, as well as the complexities of mental health. It's all about understanding the delicate balance in how we perceive reality. Let's take a closer look at some of the major visual illusions, starting with the Müller-Lyer illusion. Have you ever noticed how two lines of equal length can appear different? Well, this illusion happens because of the way our brain interprets the direction of the arrow-shaped ends at the tips of the lines. One line has outward-pointing arrows like this, and the other has inward-pointing arrows. Even though they are the same length, the line with outward arrows, which looks like the corners of a box receding into space, seems shorter. This effect occurs because our brain is applying depth cues. It's trying to interpret the 2D image as a 3D scene. So, it perceives the arrows as corners or edges in space, which influences how long we think the lines are. This example highlights how perception isn't just about the raw sensory data. It's about how our mind interprets that data based on context and experience. It reminds us that perception is an active, interpretive process, not just a straightforward reflection of reality. Now, let's take a closer look at the Ponzo illusion. Imagine two identical horizontal lines placed between converging lines, similar to railway tracks. At first glance, you might think one is longer than the other, but in reality, they are exactly the same size. The trick here is how our mind interprets these visual cues. The upper line appears longer because our brain perceives it as being farther away. This illusion really highlights how linear perspective and background context can influence our perception of size. It's a fascinating example of how our mind processes visual information based on contextual cues, which can sometimes lead us astray. This ties into the broader theme of how our perception is not always a direct reflection of reality, but is shaped by various interpretative factors. Now, let's look at the Ebbinghaus, or Titchener circles, illusion. This illusion shows us how the mind can misinterpret size based on surrounding context. Here, you see two circles that are actually the same size placed in different settings. One is surrounded by larger circles, and the other by smaller ones. Despite being identical, the circle surrounded by larger circles appears smaller, while the one with smaller surrounding circles seems bigger. This happens because of what we call relative size contrast. Our perception doesn't just depend on the actual dimensions of the objects, but heavily relies on the surrounding context. This illusion highlights a key point. Perception isn't purely sensory. It's influenced by the context in which we see things. Our brain makes assumptions based on surrounding cues, depth information, and comparisons to interpret size and distance. This is why illusions like these are so valuable in psychology. They help us understand how the brain processes visual information. They also give us insight into how perception can be biased or distorted based on contextual factors. So, through studying these illusions, we learn more about the complex ways our mind interprets reality beyond what our senses alone tell us. Now, let's explore some advanced visual illusions where context really changes our perception of reality. These illusions often stem from false cues related to depth and distance, which can cause us to see sizes and shapes that aren't actually there. They show us how powerful visual context, angles, and perspective can be in shaping what we perceive, sometimes overriding what our senses are telling us. One of the most fascinating examples is the Ames Room illusion. This is a specially constructed room that's deliberately distorted. When you look at it through a small peephole, it appears to be a normal rectangular room. But in reality, the shape is trapezoidal, and this distortion tricks our depth perception. What's really interesting is that people standing at different corners of this room can look enormous or tiny, even though they are actually similar in size. This illusion works because of the forced perspective created by the trapezoidal shape, which misleads our brain into interpreting the scene as normal. It highlights how our assumptions about geometry, like expecting rooms to be rectangular, can distort our visual interpretation. So, this illusion is a perfect example of how our perception can be fooled by context. And it ties back to the overall theme that perception isn't just about what we see, but also about how our brain interprets visual cues. Now, let's explore some advanced visual illusions, where context really redefines reality. On this slide, we're focusing on the moon illusion. You've probably noticed that the moon looks larger when it's near the horizon compared to when it's high up in the sky, even though its actual size doesn't change. This is a fascinating example of how perception can be misleading. The reason for this illusion is that we perceive the sky as a kind of flattened dome, and because of this, when the moon is near the horizon, our brains interpret it as being farther away, which makes it appear larger. This ties into the idea of distance perception affecting size perception, something we call the distance invariance hypothesis. Essentially, our perception of size depends not just on the actual image on our retina, but also on how far we think the object is. Understanding this illusion highlights the importance of visual perception as a whole. It shows us that what we see isn't just a direct reflection of sensory data, but is heavily influenced by the context and depth cues around us. This interaction between size, distance, and shape perception is crucial in many fields, whether it's studying how we interpret visual information, designing buildings, or creating optical illusions in art and architecture. In essence, illusions like the moon illusion remind us that perception is a complex process. Our brains are constantly interpreting and sometimes misinterpreting visual cues, which opens up a vast area of study in visual cognition. Let's explore how perception influences and sometimes distorts our understanding of the world around us. First, it's important to understand the relationship between perception and reality. Reality is simply the actual physical world, what exists outside of us. Perception, on the other hand, is our personal, subjective experience of that world. We never experience reality directly. Instead, we interpret it through our senses and mental processes. This means perception is really a kind of personal reconstruction, not a perfect mirror of what's really out there. Now, because of this, different people can perceive the same stimulus very differently. Our perception depends on many factors like context, past experiences, and what we expect to see or feel. For example, two people might see the same object but interpret it differently based on their background or current state of mind. So why does perception often differ from reality? Well, one key reason is perceptual selectivity. Our minds filter incoming stimuli, focusing on some things while ignoring others. This helps us concentrate on what's most important, but can also lead us to miss or distort other details. Past experiences and what we've learned also influence how we interpret what we perceive. Our expectations shape our perceptions. Motivation and emotions play a role too. If we're feeling anxious or motivated to see something in a particular way, that can influence our perception of it. And finally, the environment or background cues can change how we perceive a situation. Think of optical illusions that trick our senses. All of this highlights that perception is really a psychological version of reality. It's shaped by our mind and experiences, not just by the physical world itself. So, what we perceive is always filtered through our personal lens, which can sometimes lead us away from the actual truth. Let's explore the idea of perception and reality. As we see here, perceptual illusions teach us some fascinating lessons. They demonstrate that perception is not just a passive recording of sensory information. Instead, it's an active mental process where our mind interprets what we see. Our brain makes assumptions about size, depth, and perspective, which can sometimes lead us astray and create illusions. These perceptual errors reveal how our brain constructs meaning, even when the input is incomplete or ambiguous. This highlights a key point. Perception is both accurate and creative. It's efficient for our daily functioning, yet it's also prone to distortions. Understanding this dual nature helps us see why our perception can sometimes differ from reality. Now, on a psychological level, recognizing these perceptual differences is crucial because it helps explain the diversity we see in human thought, judgment, and behavior. It also has practical applications in fields like design, advertising, and visual communication, where manipulating perception can influence how experiences are received. In psychology, studying the gap between perception and reality deepens our understanding of how cognition and awareness work together. It shows us that perception is not just a straightforward reflection of the world around us. Instead, it's an active process where the brain interprets, organizes, and even reshapes what we experience. In summary, perception doesn't simply reproduce reality, it interprets and reconstructs it. Illusions and perceptual errors remind us that what we perceive is filtered through our mind, making perception both a reflection of the world and a creative reconstruction of it. Let's delve into the key points of this unit. Perception is essentially how we interpret sensory input to make sense of the world around us. It's active and interpretive, meaning our brains are constantly working to organize what we see, hear, and feel, often influenced by the context and our prior knowledge. This helps us navigate our environment effectively. When it comes to depth and distance perception, our ability to see in 3 dimensions and judge how far or near objects are is crucial. We rely on 2 main types of cues: monocular cues, which include size, texture, interposition, and perspective, and binocular cues, like retinal disparity and convergence. These work together to give us accurate spatial awareness, helping us orient ourselves in space. Moving on to movement and size perception, detecting motion allows us to understand the direction and speed of moving objects. We use retinal motion, induced motion, and apparent motion for this. Size perception involves maintaining size constancy, which means our brain keeps objects appearing the same size despite changes in distance. This consistency is vital for our daily activities, ensuring our perceptions remain stable even as conditions change. All these perceptual processes are interconnected and essential for a coherent experience of the world. Let's wrap up with some key insights from our discussion on perception. As we've seen, perception is not just a passive reception of sensory information, it's a constructive process in our minds. It involves integrating sensations with our attention, memories, and prior experiences to create a coherent picture of the world. We also explored how perception can sometimes be mistaken. Errors like illusions and hallucinations reveal that our perception is highly subjective and influenced by mental processes. For example, illusions like the Müller-Lyer or Ponzo show how our brains interpret visual cues differently, sometimes leading us to see things that aren't actually there or misjudge distances and sizes. Hallucinations, on the other hand, are perceptions without any external stimuli, often linked to mental or neurological conditions, reminding us how complex and delicate our perceptual systems are. This brings us to the core idea that perception is a dynamic, active process. It's constantly filtering and constructing our reality based on both sensory input and internal factors. Our perceptions are shaped by our experiences, emotional states, and expectations, which can sometimes lead us away from objective truth. The most important takeaway here is that human perception is a blend of objective sensory data and subjective interpretation. While it usually helps us understand our environment accurately, it's also prone to being misled by context, expectations, or cognitive biases. So, perception is both a creative process and one that can sometimes deceive us, highlighting its fascinating complexity and importance in how we experience the world. Thank you so much for watching. I really appreciate your time and attention throughout this presentation. If you found the content helpful or inspiring, please don't forget to give a thumbs up like to show your support and bell subscribe so you never miss out on more amazing videos from us. Remember, this is all about learning, growing, and sharing knowledge together. This team here, Skills Sapphire, is dedicated to bringing you valuable insights and quality content. Once again, thank you for being part of this journey. We look forward to having you with us in the next video.